So in this video, I'm going to go over coterminal angles. This is usually found in a trig class, either in the upper levels of high school or in the junior college level. All right. So some things we need to know is, what is a coterminal angle? Well, coterminal angles are angles that share an initial side and a terminal side, and you got to think of this on a Cartesian plane. Okay, so let's talk about what we know. For quadrants, we always start in the first quadrant, which is the top right quadrant, and which is reverse, sorry. I'm in a camera, and there are 360 degrees in that in the Cartesian plane. So whenever I'm doing this, okay, a coterminal angle is just add or subtract 360. If I'm adding to find the positive angle, then I'm going to add 360 and I'm going to go around in the counterclockwise or the clockwise direction. If I'm doing negative, I'm going to go in the counterclockwise direction and subtract 360 to find the rest of that degree. All right, that of the full degree. Now the only times that this gets a little complicated is when we are given degrees that are bigger than 360, and we are going to look at some of those. So I'm going to do a couple examples with you, and hopefully this all makes sense. So I'm going to talk about coterminal angles, so let's go over some of the logistics. So this is my Cartesian plane. This is y. This is x. This is a positive quadrant, quadrant 1, and that's because my y and my x are both quadrants, and we got to think of this as division. Okay, our x's and y's are their proportionality is they're in division, so two positives make a positive quadrant. Okay, this is my second quadrant, and this one is positive and negative. If I have positive over negative, that's going to give me a negative quadrant. This is my third quadrant, and it is negative. Negative, two negatives make me a positive, and this one is negative positive, which is going to give me a negative, and it is also my fourth. All right, so they kind of go diagonal of each other. Okay, so all a coterminal angle is, I know I gave you the super fancy one, but just remember it, they're all the same angle. Okay, so let's say that I have a 40-degree angle. It's right here. Okay, all right, this is my initial. I always initially start on the axis, either the x or the y. Let's not talk about y's yet. Let's always try to start from an x. And I go to the terminal angle. So these are all, so think of let's do a little bit of English. Sometimes if you're having trouble with this, that means you're more Englishy, and this might help. If I have a co-worker, we're both working for the same place. Okay, but we may look different or have different functions. That's exactly what a coterminal angle is. They're all the same angle, they just look differently. Okay, so let's do a little review. There are 360 degrees in a full Cartesian plane. So I start at initial, and if I go round to the terminal side, okay, I just went 40 plus a full 360, okay? So my first angle is the 40 degrees. The next angle would be 400. It's not any different, okay? It's still, if I take out the 360, will be a 40-degree angle, okay? And it's still in that terminal position. It starts at the same initial place, and it ends at the terminal side. It just looks different. All right, so let's go ahead and do another one. Okay, so I can start at initial and go, I'm going to go around 2. As long as I stop at the terminal, I have a coterminal angle. Okay, and so my next coterminal angle is going to be 760 degrees. And I could keep doing this all day. As long as I start at the same initial, end at the same terminal side, it's a coterminal angle. They all have the same initial, same terminal, and I can just keep making my little spiral graphs on my Cartesian plane. Okay, so basically the quick and dirty mathematical way of doing this is if I have a 40-degree angle, I just add 360. Okay, and that's going to get me 400 degrees. If I want to find two coterminal positive angles, I'm going to add 360 twice, and that's going to give me 760 degrees. If I wanted three positive coterminal angles, I would add another 360, okay? Because that's what I did on this Cartesian plane, okay? So let's go ahead and practice the positive, all right? So let's do 120 degrees, okay? All right, so my 120 degrees are going to be here. How did I get that? I started from my initial side, so I got to pick an x to be my initial. If I pick it in this one, though, that's x is negative, okay? And this is a positive degree. So I'm going to go from here over to here. There we go. So I draw my 120 degree. All right. The next thing I need to do, I'm going to change colors to do it, is I'm going to go from initial to terminal. Okay. So I'm going to go from here, and I'm going to go past and around here again. Okay, it doesn't change anything. I still have the same initial and the same terminal on this angle. I just went around once first. Okay, so let's go from my starting point. Okay, so from my starting point to the end of this quadrant is 9. I'm flowing in the positive direction because remember, positive is counterclockwise in a Cartesian plane. Okay, so there's 90 degrees. There's another 90 degrees, so I'm in the positive direction another 90 degrees, and I'm another 90 degrees in that quadrant, and I'm another 90 degrees in this quadrant. And then lastly, I go my 120 degrees. So you should know that 90 plus 90 plus 90 plus 90 is 360. And then I add my 120 angle, which is going to give me 480. So this is how some super mathy people, some really smart people in the math world came up with the quick and easy way. I just add 360 to my angle to find the positive coterminal angle, and then you would have found 480. Okay? That's all it is. That's all it is. All right, so let's talk about negative coterminal angles here in a minute. The negative coterminal to these, so we're going to go back up to 40, and I'm going to talk about how to find the negative coterminal. All right, so same 40-degree angle, same initial and terminal side. Okay, remember, it can be a coterminal angle if it shares the same initial and terminal side. So, in our negative one, so in my negative coterminal angle, okay, I still do everything the same that I've been doing. I'm still flowing counterclockwise. Some people like to reverse it. They like to start from here. So now I'm going in the negative direction, and I'm going to here. Okay, I still have the same initial and the same, terminal side, but I'm going in the clockwise direction now. Okay, so everything I do, I have to do in the negative direction. Remember, when you're trying to graph a negative angle, you go clockwise around the circle. Okay, so like, just for a sidebar, if I was trying to do negative 20 degrees, I would go this way 20 degrees. Same general thing. So now all my degrees are negative, okay? So here I went a negative 90 degrees, a negative 90 degrees, a negative 90 degrees, and the rest of this is actually, if this is 40, this is 50. Okay, so a negative 50 degrees. All right, so these three are going to give me a negative 720 minus another 50 is going to give me a negative 320. All right, so that's the visual way of how I do this. It's still a coterminal angle because I still share an initial and a terminal side. Okay, I could find two negative coterminal angles by starting from here and going around twice and then getting to my terminal side. I still have the same initial, the same terminal side, so it can be a coterminal angle. It's just now I have to go around 2 times. Okay, so it's like subtracting the whole thing twice. Okay, so I believe, if I'm correct, that's going to be, what am I doing? That's going to be 640. Negative 640 would be the next negative coterminal angle. Same initial side, same terminal side. That's all you have to be coterminal. All right, so someone a lot smarter than me in the math world said, we gotta have a quick way. Can't draw Cartesian planes every time I want a negative coterminal angle. So all you have to do is the opposite of what we did, finding the positive. So I have a 40 degree. I'm now going to subtract 360, which is going to give me a negative 320. If I wanted to find two negative coterminal angles, I would subtract 360 2 times. And let's see if my quick and dirty math was right. I can already tell it wasn't. So it's actually negative 680. Man, I was 40 off. Okay, so that's what I'm essentially doing, is I am going around the circle but keeping the same initial, keeping the same coterminal terminal side to the angle. As long as I have those two things, I can go around the circle as many times as I want, either in the counterclockwise or the clockwise direction. So counterclockwise is positively going around the circle. Clockwise is negatively going around the circle. All right, so let's do the 120 that I did. Okay, so let's start again. Gonna make my 120 again. Terminal side, initial side. As long as I keep those, I'm good. We already did the positive, so let's do the negative. So the negative means I flow in the other direction. Okay, so I'm going clockwise around. All right, and I start from my initial, and I'm going to go to my terminal. So I have the same initial side to my angle, same terminal side to my angle, so they're co-angles, okay? So I went negative 90 degrees and another negative 90 degrees there, and then this one, if this is 120, this has to be 60 degrees, right? Because it has to make 180. So this is a negative because I'm flowing in that direction. All right, so this is going to give me a negative 180. Okay, so negative 240. All right, and of course, like I said, the super smart people of math said all you have to do is subtract 360, okay, and you would get a negative 240. All right, so that's how I find coterminal negative and positives. Now there are a couple of exceptions. Okay, some of the exceptions that we have, they're not actually exceptions, they're just a little bit harder to do. The first harder thing to do would be negative. So if I have a negative degree. The second hard thing to do is if I have a degree that is bigger than 360. Okay, so we're going to do those two right now. So we're following the same rules. Rules do not change just because, okay? So in this one, I'm going to do a negative 20 degrees. So first I'm going to do it visually. My degree is going to be down here, 20 degrees, initial side, terminal side. I flow in from the terminal to the initial in the counterclockwise direction. Okay? All right. So let's say I was doing this using the math. It would be through sorry, plus 360, I get a positive 340. So let's see what happens when I do it on the paper. Okay, so I have a negative 20 degrees. That's what this was. Okay, so negative 20, positive 90, positive 90, positive 90, positive direction of 90 degrees. Okay, so the only one that's negative is that first one because my degrees started out negative. Okay, so 390 degrees are going to make 360. So look, I get right back into that, and it's going to be a positive 340 because the 360 is bigger and it's positive. Okay, so that's how I find the positive angle. That's not the hard one. People have trouble with the negative. So remember, I start out with my original degree, which is a negative 20, and then I'm flowing in the positive direction, so everything else is going to be a positive number. Okay, let's do the negative of that, the negative counterpart to what I just did. So let's do the math first, okay? So a negative 20 minus 360 is going to give me a negative 380. All right? Okay. So, same thing. I'm going to start with initial. Well, I'm going to start with terminal this time because terminal is lower, and I'm going to go no, I got to start with initial. Sorry. It feels so uncomfortable to go that way, but we can do it. So I start out with a negative 20. This remaining part is going to be 70. I'm flowing in the negative direction, so it's a negative 70, negative 90, negative 90, negative 90. So nothing's changed. I start with initial and I go to terminal when I'm going in the negative direction. I go clockwise, which means all of my numbers are negative. And if I add all this up, okay. Ooh, I forgot my last 20. See this little bit here? Negative 20. I'm still going in the negative direction, so it's a negative 20. All right, so if I take my 390s I have here, that's negative 270. All right, so that's negative 90. All right, this and this will give me a negative 360. And then I have negative 20 more, two negatives, add, I get negative 380. Okay, so let me recap that one again, because the negative is the one it's not that it's difficult to do the math, it's difficult to write. I don't know why there's such a mental block with students and myself. Sometimes I look at it and I'm like, I don't want to draw that. But it's the same rules. I still start with initial. I go in clockwise direction around all the way to the terminal. Okay, so this is negative 20. Then I do this, and I'm flowing negative, so it's a negative 70, negative 90, negative 90, negative 90, and I'm not to the terminal yet, negative 20. And then I just add it all up if I'm doing it the visual way. If I'm not, I can just do it, add my 360 minus my 360. Now, sometimes teachers will say, oh, we're going to make it a little bit harder. I want you to give me the two positive angles for 320. Okay? Two positive angles for negative, not 320, for negative 20. So there's a couple different answers to this that I could do. I could do negative 20 plus 360 So I get my first one, which I already got of 340. I could do negative 20 plus 360 plus 360. It would still have the same coterminal angles, and that would be what, 700, right? Because 360 plus 360 is, wait, 6, 7, 20 minus 20, yeah. So 700 degrees. So I could get 340, I could get 700, and then there's another one, okay? If this is negative 20, another angle that would flow in the positive direction, that would have um, positive and negative, is the 340, right? I could do 700 because I could go around twice and then end there. Okay, so let's clean this up a bit because now it's hard to see what I'm trying to say. So I have a negative 20 degrees, okay? I could have my first degree, my first one be this, and that's this one right here. I could do another one. Where I go like that, okay? And that's just adding another 360. And I could keep doing that and doing that and doing that. As long as I have the same initial, same terminal, I am good to go, okay? All right, so now let's look at what happens when I'm bigger, okay? So the example that I'm going to use is 415 degrees. All right, let's first do the math. So I add 360, and if I do that, I'm going to get 775, and I am going to subtract 360. Okay, and that's going to give me 40 plus 15 is 55. Ooh, that one's not actually negative, is it? Oh, it just gave me 2 positive degrees. That is not good. What am I going to do? All right, here's the problem. 415 is a coterminal angle where I added 360 of a smaller angle, okay? So let me show you what I mean. To make 415, I got to go 360 degrees, okay? If I subtract 360 degrees from 415, I'm going to get 55, so I'm going to go about that far, okay? This is 415 degrees, a 415 degree angle, all right? As you can see, it has a terminal side, it has an initial side. I got the two things that I need to make an angle, but I'm more than 360. If I were to erase and just have the smaller angle, that would be 55 degrees. So actually the coterminal was 55 degrees, 415 degrees, okay? And then I could do another 360 added on, and it'd be 775, so on and so forth. So my small angle was 55 degrees. My bigger angle was, why won't you let me go? I drew that wrong. I need to start an initial. Was 415. That's 415 right there. And then I'm going to do the other one on the inside. If I start here and I go around twice, it's going to be 775. Okay, so they all have the same terminal, same initial. They're just adding 360 to each one. But if I minus 360, I could get that first one. Okay, so when they ask for the two positive coterminal angles for 415, give them the 55. That's what they're looking for, and the 775. All right, subtract 360 and add 775. So how do I find the negative? Because when I subtracted 360, I didn't get the negative. Well, because that wasn't the standard position terminal angle. Okay? You can't find negative coterminal angles unless you know your standard position angle, which we already know. We figured it out. 55 degrees is my standard position terminal angle. Okay? So I have to do 55 subtract 360 and get a negative 315. Okay? All right, so let's look at that. I have my 55-degree angle on my Cartesian plane. I start from initial and I go clockwise all the way to terminal. All right. And then I just subtract my coordinates. Okay, so eek. So it would be 55 minus 90, minus 90, minus 90, minus 90, until I go the whole way around. All right? Okay, so those were the two harder ones is when you have more than 360 and when you have a negative. But let's also talk about radians, okay? Because you very rarely do we do coterminal angles and we don't talk about radians. So let's get some things out of the way of what we need to know when we're working with radians. So 360 degrees, this is the degree form of how many degrees is in the Cartesian plane, and that is equal to 2 pi. That's the radians in a Cartesian plane. So this from initial to initial is 360 degrees, and initial to initial is also 2 pi. All right? All right, so let's say they give me the problem pi 6, okay? I'm still going to do the same thing, the same math that I did with my degrees. I'm going to add 2 pi and I'm going to subtract 2 pi. Now I know all of you your hearts sink because you now have to work with fractions. So put your fraction over 1. I know I'm going to have to multiply this by 6 over 6 and this one by 6 over 6. So my new fractions are, let me switch to green, pi over 6 plus 12 pi over 6 and pi over 6 minus 12 pi over 6. All right, so if I add these, okay, this is 1 pi plus 12 pi, it's 13 pi over 6, okay? And if I add these, if I subtract these, it's going to be, because this is a 1, negative 11 pi over 6. So there's the math. But you want to see it on a Cartesian plane, right? So the whole way around the circle is 2 pi, okay? Halfway around the circle is 1 pi. A quarter of a way around the circle is 1/2 pi. And 3/4 of the way is 1 pi plus 1/2 pi. Just want to show you. So that's going to make it 2 over 2, which is 3 pi over 2. Just so you guys know how we come up with 3 pi over 2. It's just adding a pi to a 1/2 pi, because every quadrant is a 1/2 pi. Okay, so if I was going to do 1/6 of a pi, that's a lot less than 1/2, okay? All right, so same thing that I have been doing, initial to terminal in the positive direction, initial to terminal. All right, so that's a positive pi over 6 with what's remaining in this circle, which would be, let's see, if I was doing this, 3/6, 1/6, 2/6, okay, pi. All right, and then that would be a whole pi over 2 plus a pi over 2 plus another pi over 2. Each quadrant is pi over 2. All right, so 1, 2, 3 pi over 2's are going to be 3 pi's over 2. You could do this a lot slower than I am, if you like, until you get it down. So a pi over 2 plus a pi over 2 is 9 pi over 2. And when I am done, I'm going to get 13 pi over 6. Okay? But that is what it looks like. I suggest you don't try to add all those pi's together. You're going to confuse yourself. Alright, but you should know what it looks like. If I was going in the negative direction, I'm flowing clockwise from initial to terminal. Okay? So it would be a negative pi over 2, negative pi over 2, negative pi over 2, negative what's left. Alright. Not so bad, right? Okay, let's do one that is greater than 2 pi. Okay? So in this one, I'm going to do 11 pi over 2. Now you may be asking me, how do I know that this is greater than 2 pi? Well, I got to turn it into a mixed number first to really see it. So 2 goes into 11 5 times with 1 left over. So it's 5 1/2 pi, all right? That's greater than 2 pi. I have 5 whole parts versus 2 whole parts. So this one's greater than pi, okay? So I can either put this back into degrees and then do it and then put it back in radian, or I can just do it the formula driven way. So 11 pi over 2 plus 2 pi, okay? So this is going to give me a terminal angle, but I already know this is a coterminal angle to a smaller one. And to be able to know what that is, I'm going to have to subtract 2 pi until I get down below. But let's figure out what another positive would be, okay? So I put that over 1, find my common denominator, which is going to be 4 pi over 2, add them, I get 15 pi over 2. Just for contextual, I'm going to put that into a mixed number. So 7 pi over 2. So I know I have 11 pi over 2. Another one would be 15 pi over 2. But I also know there has to be a smaller positive. So I am going to subtract, and I'm just going to put it in 4 pi over 2, because I know that if I reduce that, that's 2 pi. All right, if I subtract these, okay, 4 away from 11 is going to give me 7 pi over 2. Oh no. Oh no, that's still bigger, right? Because if I put this into mixed number, 2 goes into 7 3 times, so it's going to be 3 1/2 pi. So I know I haven't even gotten down to the root 1 yet. So one of the coterminal angles is 7 pi over 2. So I'm going to have to subtract my 2 pi again. Okay, so I have 7 pi over 2, subtract a 2 pi, which is actually 4 pi over 2, and I get 3 pi over 2. Okay? Oh, finally. I've gotten down, because if I put that into a mixed number, 2 goes into 3, 1. 1 pi over 2, 1 with pi over 2, is smaller than 2 pi. So I finally got my original standard position angle. And these are all co-positive angles to my standard position angle. Okay, so let me go ahead and show you what that looks like. So my standard position angle went to here, okay? 1 pi over 2 is the same as 3 pi over 2. It's this line right here. This is the angle. Okay, that's my standard position angle. All right, the next angle went around and came back to the terminal. Okay, that was this angle. This angle went around 2 times, so 1, 2, and then went to the terminal side. Okay, the next one went around 3 times. I know that's really sloppy, but it's just giving you some contextual look of that. All right. So now to find the opposite angle, the negative angle, I have to figure out this little bit, right? So now I have my 3 pi over 2. And I can subtract 2 pi because I'm finally down below 2 pi. Okay, I'm not a full circle. All right, so 3 pi over 2 subtract 4 pi over 2. And I am going to get a negative pi over 2, which makes sense because a quadrant is pi over 2. And that's what's left. That's what I didn't fill, was this quadrant. And that's going to go in the negative direction, negative pi over 2. So it all makes sense. Coterminal angles, they share a terminal side and an initial side. You're just going around the circle. As long as you have the initial and the terminal in there, it doesn't matter how many times you go around the circle. To be able to do that mathematically, you're just adding 360 and subtracting 360. We have to be careful of our negative angles when we do that, and most importantly, angles that are more than 360, we got to find the standard angle that we use that was less than 360 first, but it still has to share the same terminal and initial sides. All right, so hopefully that helps you. If you want me to do a particular problem, put it in the comments and I can make another video. And please subscribe and check out my website, homeschoolmathmom.com, and subscribe to my newsletter. All right. Okay, so to recap, coterminal angles are angles that share a terminal side and an initial side. We can find the coterminal positive and negative angles by adding 360 and subtracting 360. But remember that if an angle is greater than 360 degrees, you have to find that standard angle. So keep subtracting 360 until it's below 360. And then you'll be able to find the negative coterminal angle by subtracting another 360. Please like me below by clicking subscribe, and you'll hear all of my math videos, get all of my math explanations to how to do all of your math stuff from pre-algebra all the way to trig. Also, if you're teaching math to either a group of kids or homeschooling, check me out at homeschoolmathmom.com and subscribe to my newsletter, and you'll get all my tips on how to teach this, fun games and discovery projects that I do with my child as I unschool her in math. And if you decide you'd like me to teach you math, check me out at the link in the comments below for my profile at outschool.com and enroll your 18 or younger child in one of my classes.